let's talk a little bit about the equivalence between block diagrams and bond graphs. In this case, on the left-hand side, we have represented a block diagram of an element A in this case that interacts with element B in a system. How does it do it? A applies, let's say, like a force on B, and B reacts with a movement. So there's always this interaction, action, reaction. Okay. So A applies the force. In this case, we're going to generalize the variable and call it the variable effort. And then B responds with a flow. Okay, that's also another generalized variable. This same thing that you see in here, the interaction between A and B with in this block diagram where A applies uh, applies an action to B, B reacts. All right. That same thing can be expressed with a little picture down here, because what happens is that if you if you have it in here that A applies, let's say, a force on B, this vertical line can be looked upon as if it would be like a little piston, and if you hold it here and push it from A to B, it makes logical sense the way it's driven. Because if you hold with your hand, let's say, just imagine you can hold with your hand the green bar, and you press it from A to B, it is this horizontal one that is creating the ability for you to press on B. But at the same time, we react, and B, yeah, okay, in this case, B reacts with this other flow variable, with the line. So red means the action, green means the reaction. If you have this representation like this with the vertical line and the horizontal one, this is a bond graph. But we could also call it junction graph or connection graph if you want to make it a little easy. But if we apply on A and then A responds to B, okay, you have in here this representation for this action reaction type of thing. On the right hand side here, we have now that B is the one that sends a signal E to A, and A reacts with a flow variable. So in this case, E presses on A reacts. How do we represent that same thing over here? Just hold this as if you hold the green line with your right hand or left, depending on whether you're left or right handed, but you hold it with the right and push it towards A. Okay, if you press your right hand B to A, you have this so-called causal stroke. And then from A to B, there's this junction line. So why do we need this? We need this to establish how the elements interact with each other within the system. But this assignment of this action variable. I call it action variable. This very this is called causality and indicates who causes what to whom. So A applies the effort on B. That's what it means. Or like in this case, B applies the effort on A. Yeah. So we have this figure in here where we'll see that B is the one applying the effort on A and A is reacting. Okay. Any question about this?